So yesterday we started with quadratic maximum minimum. We've started, guys, let's keep it down. We started with quadratic maximum minimum. Some of us are not here. And somebody asked a question yesterday, I think it was Alex, when I was leaving. But of course, because he had another class, there was no time to explain. And Alex's question was, why do we equate x plus m equals to 0? Do you remember that part? So he was asking the question, why do we need to do that to get the maximum or minimum coordinate of x? I'd like to show you something about behavior of graph. It's not something you will know now. You probably do that when you're doing something on graph in Form 5, Form 6, and stuff like that. So remember yesterday we agreed that this is the shape, right? If you sketch this is the shape. How do I get the x coordinates? I equate this to 0. So I'm going to get x is equal to 0. So which means this is point x is equal to 0. Like that. On the line. Okay? If this is plus 1, it means it intersects y at 1. Something like that. Does that make sense? If I have y equals x squared minus 2, it means it intersects y at minus 2, so what would that look like? But x is not equal to 0 at this point anymore. Oh, I'm missing something. X is not equal to 0 anymore with this one. Let's make this a minus 1. In this case, the root of this equation is no longer 0. The first one is the 0, 1. Okay? The first one is the 0, 1. And y is not here. So let me take one after the other. X is equal to 0. How do we know the point of intersection? You solve x squared is equal to 0. The only value is 0. So it's going to touch at just 1 point. And x squared is the same as this, right? So which means the y-intercept is also 0. Okay? Like this. So it means the y-axis is a line of symmetry. Do you understand that? So if you have this y part tells us how the graph, this shape moves along the y-axis. By having minus 2, it means this shape is going to be dragged down 2 steps. So something like that. So this is what we used to have. And now with this, I'm changing the color so we can see. This is 1, this is 2. So I'm going to move this shape the way it is. 1, 2. So it's going to be something like this. This shape, x squared is like this, okay? So it's going to just move down by 2 steps. That is the negative 2. Okay, movement along the y-axis is determined by that constant. Are you guys following what I'm saying? If I have y equals, let's take another color. If I have y is equal to x squared plus 3, it means from the original x squared position, which is here, what happens in this case?
Moves up.
Move up how many times? 3 steps. So 3 steps means step 1, step 2, step 3. So it's going to look like this. And it makes sense. Does anybody remember when, I think it was him that asked a question, Kata asked a question yesterday, do we have any possibility where it does not touch the x-axis? Does anybody remember this? Yeah. Now look at this. Why do you think it doesn't touch this graph?
Because it's above x.
No. Like if we solve this, this is x squared plus 3 is equal to 0. It's always the point where it touches the graph. If you solve this, you get what? Plus or minus square root of 2. Do you know what I mean by solve? When you equate it to be 0. This point where it touches it, this is something we are still going to do in graph. The point where it touches x-axis is the solution. So if this was, let me change this to 4 to make it easier, to make life easier. If this was 4, it means this is negative 4. Okay? When you solve x squared minus 4 is equal to 0, what do you get?
X is equals to 2.
No, not complete.
Plus or minus 2.
Plus or minus 2. That is why this point would be minus 2, this point would be plus 2. Does that make sense? For x squared is equal to 0, the only thing you get is x is equal to 0, so the only point is touching x-axis is 0. Does that make sense? But for x squared plus 3 is equal to 0, what do you think happens?
X is plus or minus.
You cannot find the square root. So it's going to be x squared negative 3. X is equal to square root of negative 3, which is a complex number. That is why the guy is above the x-axis, like this one. So the roots are complex roots. They are not real roots. If the roots are real, it's going to touch the real line. If it doesn't touch the real line, then there's no real root. So that explains why this guy jumped above the line. Is that understood? Yes.
But what if it's positive 9?
The same thing.
Because it can't be negative.
That would be positive like this.
Yeah.
So what do you think will happen? Anyone answer the question? You still cannot. It's going to be negative 9 here. Square root of negative 9 actually is 3i. This is not, this is a complex number. So it means it is above there at point what? 9. If it's not touching it, if you solve, you know, the same way we solve equation 5x plus 6 is equal to 0, we get x minus 3, x minus 2, right?
Yes.
We get x is equal to 3, and we get x is equal to 2, right? Is this minimum or maximum shape?
Minimum.
Louder.
Minimum.
Minimum. So it's going to look like this. This 3 and 2 tells you where it crosses the x-axis. So this is your x-axis. This has to be your 2. This has to be your 3. What is the y-intercept?
Plus 6.
Plus 6. So it means our y-intercept, depending on where your y is. So may I do something like that? For example, no. Your y-intercept will have to be outside like this. Something like that. No, it has to be here. Because this is 2, right? This will be 0 on this part. Do you agree? So my y-axis will be here. So when this guy goes up, it means at 6. So that's the shape of the graph. Do you understand? To know where it crosses x-axis, you solve the equation, the expression. You put it as equal to 0, you solve it. This is not something we are supposed to do now. This is something you are supposed to do later. But I want to use that to explain something. That's why I'm mentioning it. Am I making sense? So can you see why this graph behaves like this for now? Now that is the movement along the y-axis. Movement along the y-axis is determined by that constant you added to x squared. Because x squared normally is just this parabola, which is symmetric about y is equal to y-axis. Do you understand? So if it is 0, it's on this part. If it is plus 3, it's at the top. If it is minus something, it is at the bottom. Okay? Any question? Any question, please? What is your question?
Well, I understand that, but later can you explain what you guys did yesterday?
Is this about what we did yesterday?
No.
Do you have a question with this? Thank you very much. Any question, please? Thank you. Now, the other part is in here. So look at this. Y is equal to x squared plus maybe, let's say y is equal to x squared minus 4. Instead of this, I change this to, this is my x squared. Instead of having x squared, I have maybe x plus 3. This is the horizontal movement of the graph. So the same graph, this one, for example, okay, let's say let me start with this one again. Remember, this is on that and that. Do you agree? When I put negative 4, it means it's going to come here. This plus 3 tells you the movement on the x-axis. However, Plus 3 is the movement on the left. Plus is when it moves towards the left. The reason is because when we solve this, x is equal to minus 3. So x is equal to minus 3 means it's going to move 3 steps on this side. When it moves 3 steps on this side, remember it's moving 3 steps on this side. 1, 2, 3. It's going to move 4 steps below. 1, 2, 3, 4. So this same shape has come here now. Do you understand? So the bottom line is, this point is your negative 3 and what? Negative 4. So what is the value of x at this point? Is negative 3. This is the reason we equate this to 0 by default. Because this tells us the movement on the x-axis. If I give you another scenario. If I have y equals x minus 2 squared, maybe plus 3. This y is equal to plus, when will I get y is equal to plus 3? When everything here vanish. Right? When this vanishes means when this is equal to 0. Okay? So my y is equal to plus 3 is my maximum value or minimum value, depending on what equation this is. Okay? Now, we start again from this point. I draw the original one in blue. Let's see. The original one, I mean x squared plus 0. Can you see that? Weights, that's my red marker. Weights plus 3. What does that give us? What does that tell us? Above by 3. So 1, 2, 3. So it's now on this line. Okay? Weights minus 2 on the right. How many steps? 2 steps. Are you with me? 2 steps to the right. 1, 2, for example, like that. So it means this spot is now here. Okay? Then it's going to look exactly like this. It means this equation has a complex root. Are you with me? So this point is what? X is equal to 2, y equals 3. So the turning point is x is equal to 2. And that also justifies that when this bracket is equal to 0. But this is something, this graph behavior is something you will learn when you get to maybe Form 5, IB Form 5, basically. You should have learned it before you get to Form 6. It's something you will learn later. So that is why I just tell you, equate it to 0. Because you don't need a reason now. But I just wanted you to know ahead. But you don't need to memorize why now. But it's always nice when you see something, you know what the graph looks like. Because the next thing I want us to do on Friday is to do some graph sketching. And this will help us to achieve that. Even though we don't need that for now. So we could just add it and learn it before we move to the next topic. Yes, please.
Well, you only have y equals something, you can't find it.
When you only have what?
If you only have an equation y equals to x minus 1, you can't find if it's a maximum or minimum. Right?
Give me an example. Y is equal to what?
Just give it like that one.
Like x squared.
Yeah. No, x minus 2 squared.
Oh, okay. X minus 2 squared plus 3.
Can you find the minimum?
You can. Who can tell me if this shape is going to be maximum or minimum?
Minimum.
Why is that?
X
X is
squared.
positive.
It's going to be positive. Remember, if you expand this bracket, you're going to get x squared. X squared means 1x squared. Right? And 1x squared means it is a minimum shape. Okay? So if it is a minimum shape, where is the minimum point? That is where this x and y value comes in. What is the minimum value? Negative 3. You see, it makes sense. It's coming down all the way up, and this is the minimum value, indeed, on the y-axis. There are other values on the y, but for this shape, you see, there's a particular y value here, there's a particular y value here, there's a particular y value here, but this is the minimum of them. And that is at y is equal to 3, this one. So this is your minimum value. But your minimum point is both x and y combined. That's what we talked about. How do we get the x? Equate this bracket to 0. How do you get the y? Pick the guy standing alone. Does this make sense? Okay? So the reason why we equate to 0, we just tell you equate it to 0. But it's because of the way the graph, behavior of graph that you will learn later. But you don't just need it. Just as you remember, before we learn the quadratic formula, we already started using it. X equals minus b plus or minus. Most of us don't know how the formula came about until we learn the completing the square method and we prove it ourselves. Do you remember that? So exactly. If we had started with quadratic formula, maybe for you from Form 2, many of you will be confused. But we just tell you, oh, area of a circle is pi r squared. How many of you can show me why the area of a circle is pi r squared? Well, you just use it. Because when the time comes, you will learn why. If you need to learn why. Okay? Area of a triangle is half base times height. How many of you can show me why the area of a triangle is half base times height indeed?
Why is it half base times height?
That is not the class for today. However, just look at the area of a rectangle and divide it in two. That's the approach.
That's right, test.
Okay? So, and things like that. There's a lot of different things that you don't need to worry about why. Why is the Pythagoras theorem a squared plus b squared equals c squared? You know, different ways. So sometimes you just, oh, this is how to do it. When the time comes for you to learn why, you will. But I just wanted to mention it because we are going to learn this also next class. Okay? So let's just take one or two examples. I told you yesterday already that when we come today, we will take one or two examples of something we did yesterday. Then maybe I solve the 3 questions I asked you to try from home. Okay? Or did I take a different question? What do you guys think?
Take a different
Can I take a
question.
different question?
Different question? Okay, great. Which question did I, because I had like 12 here. I want to know which one I asked you to do from home. Give me the first question.
X squared minus 2x plus 4
Minus 2x
plus 4
plus 1
plus 4.
plus 4. X squared minus 2x plus 4. Are you sure it's x squared, not minus x squared?
No, it's
X
Alright,
squared.
so I do this one. Yes, another one.
X squared plus 5x minus 6.
X squared plus 5 minus 6.
plus
Yes.
And then a negative 2x squared minus 3x plus 7.
Plus 7? Yeah. So I gave you 1 and 10 from this paper. So I can pick any other one from this paper. Okay. So we're going to start with number 2. How many minutes? I don't take my wristwatch time. So.
like 15.
We still have about
20 minutes.
more than that anyways. 20 minutes. Okay. So let's see. I start with this. So the general question I just say find. If I don't want to say find maximum or minimum point, what do I say?
Find turning.
Find the turning point. Find the turning points. Okay? And you, of course, will state the maximum or minimum value depending on the nature of the question. I will advise that we listen so we don't ask unnecessary questions later. So the first one, y equals x squared minus 6x minus 9. This wasn't the one I gave you yesterday, correct? Okay. So we're going to do this together.
No, that's it.
Yes.
Did this yesterday.
In class.
What?
Did this.
I did this in class?
Yeah.
Okay, so we changed it. Why don't I change? Because I'm trying to look at the one where, okay, I just changed it. I pick the next one I have here, minus 3x minus 7. We didn't do this in class, right?
But you give it to us.
No, I didn't give this to you.
Yeah, you did.
Oh,
Oh, wait, no, it's different.
that's plus 7, sorry.
Did I give you guys everything? Okay.
Yes. This comes a worksheet.
No, I don't want us to do that worksheet thing now. I want you to have like some self-practice and I can take my time to prepare the worksheet on this. Okay, so according to the clue, what is the first clue of the step that I wrote for you yesterday?
Right in the A bracket.
Write in that form of square, okay, in form of perfect square. Do you remember that?
Yeah.
Okay, so that's the first thing we're going to do. So y equals x squared minus 3x. Then what do? We leave gap, we move 7 away. We know we're going to add and subtract the same thing, so we don't change the question. What is that same thing?
Half times
Half times negative what?
3.
Negative 3
Bracket of.
bracket square. Can we divide this?
No.
So what do we say? Negative 3 over 2 squared. So we had negative 3 over 2. We subtract it immediately. So the expression has not changed. Okay? The first 3 automatically gives us a perfect square. So y equals x minus 3 over 2 all squared. We evaluate the next LCM. I'm going to ask you to leave if you do not pay attention. What do we get?
9 over 4.
Minus 9 over 4, right? Minus 7, of course, over 1. Right? So this will be what? Over 4?
28 over 4.
28 over 4. So what is minus 9 over 4 minus 28 over 4?
Minus 37 over
Minus 37 over 4. So that will be y equals x minus 3 over 2, then minus 37 over 4. Does that make sense? So once we express that, what does the next step tell us? Look at your book, please.
Equate x minus 3 over 2.
So we equate this bracket to be equal to 0, and that's what I've tried to explain, how that is related. Okay? So equate this part to be 0. So we are going to put the bracket equal to 0, and that gives x is equal to what? 3 over 2. So this is the point where it turns. This is the x value at the turning point. Listen, if the question says find the value of x at which this turns, this is where you stop. Okay? Find the value of x at which this thing, where this function turns. This is where you stop. We just need the x, nothing more. If the question is find the value of y at which it turns, you just pick this guy. Nothing more. But the question asks you for the points, coordinate of point. That is when you bring them together. If the question talks about the value, you pick the value, you call it the value. The value is that y value. Any question? Okay? Hello? Everybody understand? Yep. Alright, so we know this. Is it maximum or minimum?
Minimum.
Minimum, because this is positive. Okay? So I put that here. Since a is greater than 0, it is what?
Minimum.
Minimum. Okay? So how do we know the y value? So minimum value is what?
Negative
37 over 4. But minimum points, what is minimum points? 3 over 2,
right.
negative 37 over 4. Any question? Answer? Any question? So I want us to do one that looks a bit complicated, and that's the end. Then I give you something to try on your own in class. 2. Look at this. F of x equals negative 4x squared minus 7x plus 1. This is just the same trick that we have done before, right? The major thing is express it as that bracket square. I believe everybody should remember to express this. What is the first thing we do?
Divide by negative 4.
I want to hear others. I don't want to hear from you. You can't divide by 4 because it's not an equation. You can't divide by negative 4. Don't talk. I don't want to hear it. What is 4? Factorize. You're not dividing. It's not an equation. Remember, you need to review that if you have forgotten how to do it. Are you sleeping in your hand? To factorize. Okay? So is equal to, so how do we factorize? Remember, this guy has no business in it at first. So if I bring minus 4 out of these two, what do I get?
X squared.
X squared. Louder.
Plus.
Minus, plus, which one?
Plus.
Candy, I don't want you to say anything.
Fine.
7 over 4x. Okay? Okay? Because I need everybody to know what we're doing, so I don't want that to say anything. And Kelly, please. That's what we have, right?
Yes.
Then in the brackets, we do exactly what we know how to do. We release the bracket later, and everybody's happy. Okay? Do you remember this? We did this before Christmas. Am I right? Come on.
Now I have a question.
Yes.
If it's always divided by a negative value, then when is it a maximum number?
We will figure that out here. We are not done yet. But this already tells you it is going to be maximum, because you can see also from here. Okay? Alright, so -4. I change this bracket to a bigger one because there's going to be another bracket inside anyways. I have x squared plus 7 over 4x. So I'm going to add something and I'm going to subtract it immediately. And I'm going to close the bracket and this guy is going to be standing outside. We don't care about him yet. Okay? So let's figure out what this is. Half times what?
7 over 4.
Plus 7 over 4 all squared. And that gives us what?
7 over 8.
Plus 7 over 8 all squared. So this is going to be plus 7 over 8 all squared plus 7 over 8 all squared. Do you agree? So this can match while the other is going to be simplifying. Do you remember this? We did this before. Okay. -4. So I have x plus 7 over 8 squared minus 49, 64. Right? What do we do next? Expand the bracket. So expand for me quickly. -4 bracket x plus 7 over 8 squared. Speak please quickly. Yes? Who's speaking? I'm talking to all of you, not just one person.
Plus 196.
Plus.
196 over 9.
There's no need for that. 49 over what? 16. Right? Do everybody know I got this? Raise your hand if you know I got this. Okay. If you don't know I got it, raise your hand. Alright. Does this make sense now? -4 multiplies the first part. -4 multiplies the second part. Is that clear?
Yes. Okay.
And that's how the plus is. And you can cancel diagonal wise. Okay? This makes life easier. Come on guys, you need to think faster. Okay? Squared plus 49 over 16. Then I just make this what? 16 over 16. So what do I get?
64? 5?
What do I get? 65 over 16. Okay? So now we can get the x value at the turning points. What is the x value at the turning points? Somebody should have seen it. What's its value of x at the turning point? Remember I said turning point, I didn't say maximum point or minimum yet. -7 over. So we just put what? X plus 7 over 8 equals 0. Then x is -7 over 8. So that is the point of x where it turns. Okay? So it turns at that point. Then, so I can get the value. So maximum value, it is maximum, why?
It's negative.
It is negative. What is it? Since a is negative, it's a. We call it a, right? Since a is negative, then f of x is maximum, right? If x is maximum, what is the maximum value? Maximum value is what?
65 over 16.
65. Cherry. Last warning. 65 over what? 16. What is the maximum point? Negative 7 over 8. 65 over 16. And that's it. What do you get for? I don't understand. That's like this one. Do you care about this one? It just tells you if it is maximum or minimum. That's your A. Any questions? Okay, so I'm going to write 1 or 2 questions which you should try now in the class. Please do not start to copy this yet. Focus on the question in class. Solve it with me and with somebody beside you. Leave space for this. When you get home, copy it on Edmodo. You can leave it, Candy. You can leave it, don't. So, try this question.